Welcome to part 2 of Competency 9 quiz. In this video, we will answer questions relating to trig functions and identities. Number 7, use the diagram below. And what do they want us to do? What is the value of AD? Okay, I see what's going on. Okay, we've done one of these in other videos. Very similar, but in that one, I believe we were provided an angle and a leg length. In this case, they're asking us to find this segment length, okay? All right, but they do give us one entire leg, which actually is extremely, well, I was going to do that a different color so we could, because that's not what we're looking for. Yeah, this is good enough. This is what's given, okay? And they're saying, hey, this is a 40 units, okay? All right, well, we know what to do with that. There's a couple ways that we can handle that, but I'm thinking the best way to handle that is to look at this 54 degrees and the fact that it's a right triangle and we have 40. So my thought is we could get this leg and we'll call it B. Okay, we'll call that guy B. And then that would give us at least, yeah, sure. We need that first. Absolutely. Okay, so I'm seeing tangent because I see opposite over adjacent. So this means that we have tangent of 54 degrees equals what we're calling B, okay? And the reason I'm calling that leg B is we want to call what we're looking for X, just to keep that straight in your head. Okay, then we're going that because we're using the 54 degrees, we need to use the 40. We're using the large triangle first, okay, to find that length. So we have 40. So obviously, to find that, we just multiply both sides by 40. And this means that our 40 over 40 cancels out. And this is what we need to get B. So let's put that in the calculator real quick. So, and if you noticed, I wrote this incorrectly. You see what I did? The degree measure is written by the number, not outside the parentheses. It isn't an exponent. Okay. All right. And now that that's been said, okay, so we have 40 tangent of 54. Let's press enter. So that means here we have 55. I'm going to round that to 55. I don't always like rounding, but I think in this situation that'd be okay. Okay, so that distance is 55. Now that we have 55, we use the exact same setup to get X, except we can't use tangent. We're using opposite over the hypotenuse, or R, which is sine. Okay, so that gives us sine of the 75 degrees equals 55 over the X that we're looking for. Okay, so what do? Well, we have to multiply both sides by the X. Okay, that means this cancels out. Okay, so we then will actually be dividing both sides by sine of 75 degrees. Okay, all right, sine, I could write better here, sine of 75. Oh, well, I say that. Okay, here we go. Sine of 75 degrees. Okay, well, I'll rewrite all this to clean it up. Sine over 75, Sine 75 over sine 75 obviously is 1, right? So what do we have? That means that x, this will give us x over the 55, which is a distance, then over sine 75 degrees. And that should give us something pretty close to what we need. Like I said, 55 was rounded a bit, so we probably will need to round just a bit. Okay, so let's do that. All right, actually, we have the 55 not rounded in the calculator. We could simply just push divide and sine and 75, and let's see what happens. I see 56 rounded to 57, and yes, it does work just fine. That would be option B. That wasn't too bad at all. We're just applying the same concepts, well, basically the same thought concepts twice. Pretty nice. Okay. Basic trig identities, rather. Okay, let's look at number 8. Okay, use the diagram below. Okay, and that's our diagram. That's dual triangles. What is the measure of angle B? Okay, so let's make that a yellow. This is what we're looking for right here. This would be our theta, our missing theta that we need. Okay, so what can we do? Well, I say we just get the height from A to C, and then it should be pretty simple. Yeah, I see. Very, very basic, very simple. Okay, so what are we doing first? We need to get this h. Well, how do we get this h? Well, we can use this 36. Well, that means that we have tangent opposite over adjacent, okay? Which means that, I'm going to write it over here, that our tangent of 36 degrees equals the h over 15. Okay, well, if we multiply both sides by that 15, okay, this cancels out, and this is what we need to put in the calculator to get our h, okay? All right, 15 and then tangent 36. Let's see what happens. And that would be 10. I'm going to say that, you know what? We don't even need to round it. Let's leave it up. But we could round that to 11. Let's call it 11 and see what happens. I always hate rounding in these situations. So I'm going to say roughly 11. Okay. All right. Let's see if we get close enough. All right. So then if we go to our angle B, what do we really have? Well, we have the same situation of opposite over adjacent. So we're going to apply that tangent one more time. But this time it will be tangent of theta, right? So tangent theta equals 11 over 20. Okay. So that means we can use inverse tangent with the 11 over the 20, and we should get something decent. Okay. Let's see what we get. I was thinking, you know what? I may just pop up and grab that item above. Let me show you what I do. So second tangent, I'm putting in our inverse, okay? But then, remember the 11 is what was rounded, but that's right up here above. I'm going to arrow up, grab it, push enter to pop it back down, and then divide by that 20, close my parentheses, and that would be 28.58, which is, yep, rounds to 29. That's C. Okay, let's try that again with 11. Just out of curiosity, let me see what happens. Notice I just went up and grabbed it. Now I'll have to get rid of some things here. And let's see if we get closer with 11. Okay, notice it goes over and I have to delete all this out, but it's not a big deal. Don't push clear in this situation. Well, you could and then just start over, but I just deleted it all. Okay, let's push enter. See the difference? Yeah, either way, they were nice enough to make it very clear which item it would be. Definitely 29 degrees. Okay. All right, let's go to number 9. Number 9, for the graph f of x equals sine x, which one of the following statements is false? Okay, here's the thing. Let's just go ahead and graph that in y equals. Okay, let's clear out what I have. Okay, and let's do just sine x and graph it. Okay, of course, first thing we need to make sure is that we're in degree mode, which we are. So back out of that. Now, when we push graph, let's go ahead and say zoom and go to number 7. If you remember from other videos, there you go. It gives you a cleaner looking trig, any trig function graph, a trig function. It just going to look better. Okay, there we go. Now we know that the basic sine and cosine has some, this is the parent function. It has some very specific features. It will always have these features. One of the features, I see one of them. Now we're looking for what's not true. Okay? The first thing, the period is 2 pi. Well, we know that that is true. Okay? Uh, regardless if our calculator will tell us that or not, because in order to get the period of a function, right? Okay, the formula was 2 pi divided by b. Well, in this situation, our b is 1 and our c is 0. So 2 pi divided by 1 is 2 pi. Either way, we just know that that's a basic feature of sine x. Okay, now, the minimum value of the function is pi. Look at your graph. Doesn't it look like -1? The basic property of this, of just sine x, not if it's shifted or the amplitude changes. Now, the reason that we know that for this function that it is 1 and -1 is because here again, there is a 1 right there. There's 2 understood ones going on here. So, oh, sorry about that. Here, I was erasing. And there it goes. Okay. So we know that that is false. So we are looking for a false item, which this probably satisfies. Let's look at C. Intersection, the y-intercept occurs at 0, 0. Intersection of 0, 0. You can look at your graph and see that that's true. So that can't be it. The domain is all real numbers. Obviously, that is a property of sine and cosine. Okay. Now, it isn't a property of tangent and secant. You can put those in your calculator and you'll see that that isn't a valid property, but it is of sine and cosine. We know that for a fact. Okay, let's look at number 10. All right. With respect to the graph of sine of x, so I'll leave up our graph in our calculator. Okay, the graph of which one of the following has a phase shift of pi over 6 units to the right. Okay, here's the thing. They're asking for phase shift, and phase shift was C. Oops, I need to let me get my, there it is. I have to get my pen back on. That was C over B. Okay. All right. Now you can look at each of those. C over B. Okay. This is your C, this coefficient, and this values are B. Okay. Well, we can tell that A might be it, but B absolutely not. Oh, I'm sorry. I wrote those wrong. Oh my goodness. I bet you said, what are you doing? wrote those backwards. B becomes before C, obviously. That looks a lot better. Sorry about that. Okay, so A might be it. B cannot be it because that would be 6 over pi. That is incorrect, okay? See where that would not work. It would be the reciprocal. That's not what. Well, as long as I write it correctly, that is. Okay. And then C is, let's see, that would be pi over 1, which is just pi. That isn't it. And then D is 1 over 6. No, that's 1/6. That's not going to work. Okay. Now, let's talk about the possibilities here. Okay. We have two ways that we can write this, right? Okay. To equal pi over the 6 on either one of these. We know we have x here. We can put a subtraction there. Okay. So we have pi over something, and it's got to be pi over something. We know that 2 times 3, okay, we either have the option of 2 times 3 or 6 times 1. Okay, well, actually, that'll give us another one. Okay, and that one would be 1 here and 6 here. Okay, well, that's not what we have in our option A or the other ones. They tried to trick us with B, which if I had written it incorrectly, then yes, that would have been an option, but it isn't. I'm really glad I saw that. I can't believe I did it in the first place. Okay, doesn't matter. Okay, so for our purposes for A, we can either have 3 over 2 or 2 over 3. Okay, so that means we can have pi over 3 and then divide it by 2 over 1, which means that gives us a reciprocal of 1 over 2, which gives us the pi over 6. Because remember, they're asking for phase shift, not period, okay? All right, now, then this other one, we know that that's valid because then, here, let me erase this here. Okay, we know that that would be pi over 2, and then it would be dividing 3 over 1, which gives us pi over 2 times 1 over 3. Well, of course, that's pi over 6, okay? Okay, so that is a valid answer, A. All right, number 11. With respect to the graph f of x with sine, same sine function, sine of x, the graph of which one of the following has a period of pi over 8 and an amplitude of 5? Well, let's look at the amplitude first. Well, B and D are out because they have an amplitude of 8. A and B are in. Remember, you take the absolute value for amplitude. So 5 is it. Now, all we need to do is say for each one of these, let's do the first one. 2 pi over, this is B, okay? Well, that's 4. Well, that's going to be pi over 2, so this is not it. Well, let's double check C. Okay, 2 pi over the 16, and yes, that simplifies to pi over 8, so option C is the appropriate one. Okay, all right, this is the last question for part 2 of the quiz. And once again, thank you for watching and happy testing.